Okay, right. Let's start. So we'll finish checking one of the questions, one of the other questions on the test paper. Okay, so just a moment. Let me go back to, yeah, I'll upload the notes to the Google Classroom. I forgot last time. Okay, I forgot in the last lesson. So there was this question that asked you to distinguish between potassium chloride and sodium carbonate.
Sure.
And right. So just a moment. Right. So there's this question that asks you to distinguish between potassium chloride and sodium carbonate. There should be three methods, okay, that you can use to distinguish between these compounds. So when we say we have to distinguish between compounds, we need to test for things that one compound has, but the other does not. Okay, for example, we can look at the positive ion here. So I'll copy this 3 times. Yeah, and in the first comparison here, we can focus on just the natural ion. So one has K plus in it, the other has Na plus. So how would these two ions fare in the flame test? What color do they give in the flame for potassium and sodium ion? Lilac and yellow. Yeah, golden yellow. Yeah, calcium will be bright red. Okay, so it's going to mix up Ca with Na plus. So can you all put down, especially those who got the correct answer for this question? The first test we can do is flame test. That's because K plus will give a lilac flame and Na plus will give a yellow flame, okay, in the flame test. So that's one way to tell them apart. What other tests can we do when we look at other parts of the compound? For example, we can look at the chloride ion. You see, potassium chloride has chloride in it, but then sodium carbonate does not. What is that test would be in the lab that can test for chloride? Acid test for carbonate. Silver nitrate, acidified silver nitrate. Okay, so you may want to put down. These tests are not in any particular order. You can put them in any order you like. You can do this as your first test, and this is second. Doesn't matter the order. So you have acidified silver nitrate. Yeah, so acidified silver nitrate. And what test result will you get if you have a compound with chloride and a compound that does not have chloride? So this has chloride, and this has no chloride. Remember the positive and negative test result?
White precipitate.
White precipitate when you have chloride. So put down white precipitate. Be careful how you spell precipitate. Can you take out the notebook? Without no how many lessons and you still do not have a notebook. So white precipitate. Yes. Yes. Oh, calcium carbonate. Sorry. Okay, so this is calcium carbonate. My bad. So you have potassium chloride and calcium chloride. We just have to change the flame color for this one. My bad. So this is Ca2 plus, and then the color will be bright red. Then in this case, bright red. Okay, so put down bright red. Yes.
I got it wrong. Using I wrote calcium carbonate would cause the flame to become golden yellow.
Oh, okay. I'll take away a point here because I think I mistaken it before. Yeah. So this should be bright red. If you saw that mark it as correct, if you wrote down yellow, okay, be honest and come to me. Okay. So this is calcium, and then we have again calcium here. So the third test, okay, that we can do is to test for the carbonate. So what is that test that we can do on just the carbonate ion?
Acid.
Add acid. Any acid will do. For example, the acid in the stomach called hydrochloric acid. Okay, so add hydrochloric acid, so hydrochloric acid, or HCl. So start remembering formula of compounds now. So for carbonate, obviously this compound has carbonate. The formula of carbonate is CO3 minus, and chloride has no carbonate. Because chloride and carbonate, they are mutually exclusive, okay? So this has no carbonate because this is a chloride in place of carbonate. And what test result will you get if there is no carbonate compared to when there is carbonate? When do you expect to see colorless gas bubbles? Is it when there is carbonate or when there's no carbonate? There is carbonate, okay? So you can write down colorless gas bubbles evolve. Okay, or there's this word, right? Effervescence. Yeah, and when there's no carbonate, there will be no visible change. It will just remain dissolved. Okay, no bubbles come up, so no visible change. So that's the three tests, okay, that you can use to distinguish between two samples of compounds: potassium chloride and calcium carbonate. On the surface, they both appear to be white powder. So you cannot tell them apart just by looking at their superficial appearance. They both look the same. They are both white powders. But then when you actually go test them using the flame test by dipping a platinum wire in, shove it into the Bunsen flame, you see that they give different flame color. They will respond differently to these two tests as well. So then you can tell them apart. And can you also put this on the side and write down they are visually indistinguishable, which is why we need these tests. We need chemical tests, as physical appearance may not tell you anything. They are almost identical, okay, in terms of their appearance. So visually indistinguishable, okay? You cannot tell them apart. Now, just one more question. I will not go through each and every of those questions with you because some are quite easy, some are quite hard. I want you to go to the last one. Yeah, the last question, which was not so well done by the students. You can have all your paper for a second. Okay, I've just taken from you. So you turn to the last page, okay, of the paper. Yeah, and then you have, okay, like this graph in here, like ammonium. So you have like the several salts in here. So I'll just use one as an example. So you can see the relationship between solubility and temperature. In chemistry or in any science for that matter, there are only two kinds of relationship. One we call direct relationship. The other we call it inverse relationship. Okay? When you see that increasing the x value will result in an increase in y value, so when x increases, y also increases, we call this a directly proportional relationship. Okay? So directly, let me draw a straight line here. We call this a directly proportional relationship. So there are certain factors that are related by a directly proportional relationship. For example, the amount of time you spend studying and your test score. So generally they are directly proportional. Okay, but then there are relationships that don't go in don't have this relationship here, like this one. So we call this an inversely proportional relationship. Okay, for example, x value could be, okay, how do you know you have an inversely proportional relationship? When x increases, you see the value of y will just decrease as you continue to increase the value of x. Okay, it goes down rather than going up. So this is an inversely proportional relationship. So write down some examples. This could be the number of hours you spend studying. So you spend studying, and y could be your test score. Okay, so the more you study, the higher the test score generally. And inversely proportional relationship could be, for example, the amount of fast food you eat. Okay, and your health. Okay, yeah, how healthy you are. So how healthy you are. So you get what I'm saying. So they are direct and inversely proportional relationship. So how fast food you eat. So in this graph, apparently you see some kind of a directly, or at least they may not be directly, but they are like a positively correlated with it. That means when temperature increases, you see all four curves, they seem to like curve upward, right? So that means the higher the temperature, when I ask you about this relationship, you have to say the higher the something, yeah, what will happen to the other thing? Okay, it will also be higher, right? So you say the higher the temperature, the higher the solubility. Okay, so that's what we mean by relationship. And okay, starting from question B, that's where most students don't get the point here because there's a bit of math. When you look at the graph, can you pay attention to the y-axis? It says the solubility in gram per 100 gram of water. There's per 100 gram of water on the y-axis, right? You see. So when you read this graph, however, let's find the solubility of potassium nitrate. Which curve represents potassium nitrate? The second curve counted from the top. The second curve counted from the top. When you read this value, you need to find 48 degrees. So 48 degrees C from the X value. Can anyone tell me what is the solubility that you read off the y-axis when you extend a line from 48 degrees upwards to the curve? And yes, what is it? 18. 80, yes, 80. So this is 80 gram. Can you all find 80 gram there from the y-axis? But if you put this as an answer, you will be incorrect. Why? Because this is 80 gram, look at the y-axis now. Per 100 gram of water. That means for every 100 gram of water, you can put as much as 80 gram of potassium nitrate. But what does the question ask? Look at the question. Calculate the maximum mass of potassium nitrate that can dissolve in 200 gram of water rather than 100 gram. So you need to do some scaling. So my question is, so write this down. If 100 gram of water can dissolve 80 gram of salt, how much salt can 200 gram of water dissolve?
160.
160. Does everyone see why it should be double? Okay, yeah, if you don't see that, write this down. If 100 gram of water can dissolve 80 gram of KNO3, then 200 gram of water will be able to dissolve twice as much, okay, which is 2 times 80 gram, right? 2 times 80 gram is 160 gram. Okay, so can you put this down? Yeah, many of you did not get the answer to this, so I wanted to put this down. Yeah, so you have to deduce how much salt you can add into 200 gram of water if 80 gram can dissolve in 100 gram of water. So do you all see the mathematical relationship? When you do 100 times 2, so this is just scale. Okay, when you times it by 2, so can you dissolve twice as much salt? It's just a proportional relationship, you see. Is everyone clear? Okay, yeah. This I have to admit is a tricky question because if you did not pay attention to the y-axis, you would get an incorrect answer. Okay, so now we have the next question. Oh, the next question is easier. So the next question requires you to again draw a line, but this time it's just a vertical line. So tell me what you see now. You have 4 curves. Let me just roughly sketch it. You have this one, you have this one here, you have then another 2 curves like that. And the question, passive, is asking you to state the name of the salt with higher solubility. Yeah, for some reason, some of you wrote down table salt when table salt is not even on the graph. Okay, so this question is related to the graph. Okay, and which salt has the highest solubility at 20 degrees? And to answer this question, you need to first find 20 degrees from the diagram. Draw a straight line pointing up, like a rocket is launching from the ground. Can you tell me which of these lines, green, red? Yeah. Okay. So let's discuss this at recess. Okay, so pay attention. If you get this question wrong, especially you need to pay attention. Which of these colored curves, green, has the highest solubility, right? Yeah. So that means this salt, what is it? It is aluminum nitrate. So aluminum nitrate has the highest solubility. Because you know when you look at this part, this curve, this has high solubility, and lower down means low solubility. So the higher you go, the more soluble it is. Okay, this is a disaster. Okay, I think only one student got it right. Okay, do you remember what a saturated solution means? A saturated solution, does it have a maximum amount of salt dissolved, or does it not have a maximum amount of salt dissolved?
Maximum.
It has a maximum. I compare to like a cinema that is full house, right? Yeah, every seat has been taken. So it is asking you, a saturated solution of potassium chloride. Now you need to focus just on the curve for potassium chloride, which is this one. This very straight, like a line here. Yeah, and they're asking you if having 100 gram of water, if you cool down 100 gram of water of a solution of potassium chloride from 40 to 0, this is the most difficult one because, now take out your pen. You may want to copy this graph once more. You have the potassium chloride curve in here. You need to find 2 points now. One is 0 degree, the other is 40 degree. So this is the amount of salt that can dissolve in 0 degree water. So you can draw a glass of water and put some ice around it, because that's what 0 degree means. Okay, so when you put water around the water, around this glass of water, you have 0 degrees. How much salt can you read off the Y value? How much salt can dissolve in 0 degree of a potassium chloride solution? What is this value? Roughly will do.
24.
So this line, so remember,
22.
this is the line.
20
Not the
something.
third one, but the second
22.
20
20 something. Yeah, 20. I would say it's like 28 or 29. Yeah, because you can see where does this value sit. This value sits between 20 and 40. So if this is 20 and 40, that means somewhere in the middle you have 30. And that means somewhere here will be like around 28 to 29. Doesn't matter, roughly will do, because I did not give you a very clear scale. So let's just assume that you can put as much as about 28 to 29 grams of KCl into a 0 degree sample of water. Now, can you do the same? Find me the maximum amount of salt that can dissolve in 40 degrees now. So 40 degrees, you extend a line upwards to the potassium chloride curve and read off the X value, Y value. What is it? What is it? Yeah, you can read it. Sorry, I took away your paper. So can you extend a line upward at 40 degrees and read off the Y value?
40.
40. Yeah, 40. What does that mean? That means in a 40 degree sample of KCl solution, you can dissolve more salts as much as 40 grams of KCl. Now, this is where the problem lies. If you are holding a 40 degree KCl solution, which can dissolve 40 grams of KCl, you cool it down to 0 degree. So you're cooling it down. Oops. So you are cooling it down to 0 degree. How much salt will be forced out of the solution? It's kind of like originally in this cinema, there are 40 seats. But now the manager comes in and says, oh, we have to make a cut. I need to remove some seats. So then there are now 29 seats available. Only. How many customers will have to be leaving the cinema? 11 or 12. Yeah, so you see what saturated solution means?
Okay.
Yeah, saturated solution means it has dissolved a maximum amount of salt already. Okay, in other words, a 0 degree sample of KCl can dissolve only 29 grams of salt. But a 40 degree sample of KCl solution can dissolve a 40 gram sample of salt. So that means this is like a larger cinema. This is like a larger cinema, higher capacity. And this is like a smaller cinema. So when you move people from a larger to a smaller cinema, some people, they will not have a seat anymore, right? Because this has only 29 seats or 28 seats available, when this has 40. So how many grams of KCl will have to come out of the solution. Will be the difference of between these two numbers, which is 11 or 12. Yeah, this is the most high level question I would say. Okay, so put down the explanation. Because for that's the answer, 11 or 12. 11 or 12. So write down 40 degree KCl can dissolve. Okay, so if you're the one student who got this right, okay, you have a very logical mind. Okay, but for those of you who don't yet know the answer, now you know. 40 degree KCl can dissolve at most 40 grams of KCl. And you can underline the word at most, that's very important. What happens to those that cannot dissolve? They will come out of the solution. So a 0 degree KCl solution can dissolve only, again, at most, 28 to 29 grams of KCl. That means when you cool the solution down from 40 to 0, so when you cool the solution from 40 degrees C to 0 degrees C, you are forcing some salt to leave the solution as solid. Okay, so when you cool the solution from that, 40 minus 28 or 29, which is 12 grams of KCl, will be forced out of the solution as solid. You know, solution means they dissolve, right? Yeah, when you can do this at home. Put a 1 or 2 tablespoonful of salt into water. It dissolves. What do I mean when I say 12 grams of KCl will be forced out of the solution? You can try adding more and more salt into water. There will be a point when some salt will stay at the bottom, right? They refuse to dissolve, right? If you don't believe this, you can try, but maybe your mom will kill you because you're wasting salt, okay? And then you can tell her that you can use evaporation to get back the salt, okay? So, force out of the solution as solid. Okay, this is a very high level question. And any question on the text? This I think is the hardest one. If you can understand it, very good. Okay? So now we have to move on. Can you wake up? While I still ask you to stand for 5 minutes. Okay, so let's return to our. So I will now be distributing the worksheet on ionic and covalent compound. So last time we saw at like a discussion of ionic compound or ions. Okay, does anyone remember what are the two types of ions called? What are the two types of ions? Don't remember. Cations and anions, right? Okay, so let's do a very quick review here, and then we have to pick up from where we left. Yeah, thank you. So we have compounds and ions. So on the first page, you see the word compound, okay? And there's like a blank space there. Compounds are, what are compounds? Compounds are pure substances. So they are pure substances. Right. Thank you very much. Okay. So everybody should have a two-sided page. If your copy has only one side, you can come to me and I'll give you another copy. Because sometimes the printer it was kind of weird. Okay, it doesn't print both sides. So if your copy has only one side, tell me. Okay. If not, then go to the first page and write down what compounds are for me. Compounds, they are pure substances that contain two or more types of atoms. So two or more, write this in the blank space provided. So two or more types of atoms chemically bonded. And there are two main ways, okay, atoms can bond together. We call them ionic bond or covalent bond. So you can write down mainly ionic or covalent bond. Right, ionic bond and covalent bond. We'll look at what that means in this lesson. And below is a quick summary on what compounds are. Okay, you'll get to know more about them, ionic and covalent compounds. Let's write down a few things about these compounds first. Number one, what are ionic compounds made out of? They are made of metals and non-metals generally. But covalent compounds, they are made only of non-metals. So they are made only of non-metals. So you see I wrote 2 or more types of atoms, right? But I didn't specify what type of atoms they are. Are they metals? Are they non-metals? Are there any requirements as to which type of atoms has to bond in ionic and covalent bond? Yes. For ionic compounds, they are made of metal and non-metals. So this is what you need to fill in the blank. Metal and non-metal. Whereas covalent compounds, they are made of non-metal only. So they are made of non-metal only. Some examples. I will give you one, and maybe some of you can tell me other examples. We have aluminum oxide, which is an example of ionic compound. Can anyone give me other examples of ionic compounds?
No.
What is in table salt?
NaCl.
NaCl, sodium chloride, both correct. Okay, NaCl. And you can see that Na is a metal. If you have 2 different color highlighter, can you take it out and highlight the metal part and the non-metal part of these compounds? NaCl, or when you brush, okay, look at the packaging of the toothpaste later, you will find NaF, sodium fluoride. Okay, these are all ionic compounds because they are made of metal and non-metal. However, there are exceptions though. Okay, you can maybe put down this exception also in the example box for ionic compounds. So some ionic compounds contain non-metal only, but this is very, very rare. So this is why I wrote down generally. Whenever you see the word generally, that means there are exceptions, and these are the exceptions. Okay, just one exception. So contains non-metals only, e.g. NH4NO3, NH4Cl. These are actually ionic. Okay, but the reason why they are ionic, we'll discuss that later. So just put this down on the side in the same box first, in the EG box. Okay? Can you stand up for 5 minutes? Because you're not talking. We are working on this worksheet together. You come to learn, you don't come to stay. Then I will have to ask you to stand up. If this continues. So covalent compounds, they are made of non-metals. For example, water. Well, everybody knows water, right? What about methane? Does anyone know what the formula is for methane? CH4. Yeah. What about the gas we breathe out? CO2, carbon dioxide. Yeah, carbon dioxide. So write this down. There are many, many more examples. They are made of non-metals only. You see, I only use the color red. That's because these are covalent compounds. So the next blank we'll fill in is the at least this is better than connecting to the Zoom every time. Okay, back. Okay. We have the third blank to fill in. What are they made of? Okay, ionic compounds are made of ions. They consist of ions. The ions are known as cations, which are positively charged, and anions, which are negatively charged. Okay, so in those in this blank, just write down they consist of ions. And below you see an equal sign. Write down ions are charged particles with different number of what? What is inside an atom that are charged? Electrons and protons. But in an atom, you see these 2 particles, they are equal in number. In ions, however, they are not equal. In ions, they are not equal. So charged particles with unequal number of protons and electrons. So protons and electrons, yeah, you may need to write a bit small. Okay, so let's squeeze everything in this blank. So write down ions is equal to charged particles with unequal number of protons and electrons. What about covalent compound? Okay, what are they made of then? Well, they consist of molecules. So molecules. So what is a molecule? A molecule is a group of atoms. So a group of atoms, non-metal atoms, sorry, please add non-metal atoms. This is why you only see the word molecule under covalent compound. You will never use the word covalent molecule with ionic compound. These two terms, they are mutually exclusive. Ionic compound are not made of molecules because they are not made of non-metals. And since molecule is a group of non-metal atoms, it can only exist in covalent compounds. So a group of non-metal atoms bonded together, okay, as a single unit. So finally, we have the last blank, and then we have some hands-on activity below. They are formed when atoms transfer electron, okay, so write down formed by the transfer of electron. So the keyword is transfer. And for covalent compounds, they're formed by sharing, okay, we'll see how that works. I'm sure you will know what that means by the end of this worksheet, by the end of the second lesson now. So let's look at the next section below. Ionic compounds. You are asked to draw the electron dot cross diagram of the compounds formed between Li and F. Okay, so let's do this now. So we have ionic compound. So when you draw ionic compound electron dot cross diagram, what do you need to pay attention to? First, you need to work out the electron arrangement. I hope you haven't forgotten how many electrons go in the first shell, second shell, and the third shell. How many electrons can you put in the first shell at maximum? Two. The second? 8. The third one? 8. Also 8. So this is how you work out the electronic arrangement. What do you do next? So step 2 is to draw the ion formed by each atom. Okay? So after you work out the electron arrangement, you can find the group number. And once you find the group number, you can find the charge, ion charge. Do you remember that table where I said elements from different groups, they can form ions of different charges? Let me test you. What is the charge of the ion formed by group 5 element?
-3.
-3. Okay, so what about the other students? Let me ask the rest of you. What about a group 2 element? What can a group 2 element form? +2. +2. Group 1 will be +1. So you may want to refer back to this page of notes. Group 1, form +1 charge. Group 2, form +2 charge. This you need to remember it. I will not provide this table to you in the exam. It has to be in your head, okay? And so you see group 5 will form a 3- charge. Remember this, okay? Now let's go back here. Once you have worked out the group number, you can work out the ion charge. And the next step is to draw the ions formed by the atoms, okay? And then step 3 is to figure out the ratio. So figure out the ratio by 2 methods. Remember, there's a visual method, right? But like I said, nobody has time to use the visual method in the exam. Or you can use the crisscross rule. Why don't we use the first example here to show you what that means? The crisscross rule. Write down these 3 steps. In the exam, or when you're preparing for the exam, you should revise these steps rather than memorizing the example. Because there will be an uncountable number of examples that I can set for you in the exam, so you can't memorize each and every of them. Instead, you memorize the method, these 3 steps. Okay, let's apply it. Starting with LIF. I will tell you the atomic number, you tell me the electron arrangement. Li has atomic number 3. F has atomic number 9. Tell me something about the electron arrangement.
2 1 2
And
8 1. Wait, no, 2 7.
2 7. Do we all agree that it's 2 1 and 2 7? Okay, yeah, 2 1 and 2 7. So which group does Li and F belong to? If the outermost shell electron is 1 and 7. Group 7. Now recall from your hand what is the charge of the ion formed by a group 1 element and a group 7 element? Yes, okay, so now you can use the visual method. Oh, really quick, you're already done with step 2. So this is step 1 where you figure out the charges, the group, and then you can write this is Li1 plus, this is F minus. Now, we can go straight to step 3 now because we already figure out the ion. You can also draw the ion out. Li plus, how many electrons does Li plus have? 2. Yes, so draw 2 electrons with just one shell. Yeah, and don't forget to put a plus charge on the side. And what about F? How many electrons would F have after gaining an electron to become an F minus ion? 2 8, meaning a total of 10. Okay, so you need to add 1 electron, so gain 1 electron. Negative 1 means gaining 1 electron. Positive 1 means losing 1 electron. So the electron arrangement will now be 2 and 2 8 respectively. So let's draw them up. So for F, we draw 2 shells because it's 2 8. So 2 8 means 2 in the first shell. Use different symbols, but it's up to you. You can use dot for this one and cross for this one. Just use different symbols. Okay? So you have 1, 2, 3, 4, 5, 6. But be careful now. What should I draw the last electron in? What symbol should I draw it in?
Cross.
Cross. Why not dot?
Because it took it from the field.
Yes. This last electron didn't come from fluorine itself. It came from lithium. You see, lithium has lost an electron. This is where that lost electron go. It went to F. So this is the cross electron that came from Li. And finally, don't forget to put a minus charge. So step 3, this is where students can be creative. You can use one of 2 approaches. If you are into drawing, if you are very good at visualizing concept with the visual method, you can do this. Li plus is analogous to a puzzle with a depression. Plus means it is electron short because it has lost electron. This is why I drew a depression here. F minus, it is like a puzzle piece with a protrusion. Yeah, that's because the negative charge means it has gained 1 electron. This is why this is like a protrusion, and Li plus shows a depression. And then, well, of course, this is the visual method. What ratio can they be in to make the puzzle fit? Just 1 and 1, 1 to 1. You see, only having one of these puzzle piece and the one of the other puzzle piece is sufficient to make this puzzle like a fit perfectly, right? So this is why the formula is LIF. But then if you don't like this method, we can use the crisscross rule. Do you remember how the crisscross rule works? We take only the number part with us. We swap them, and we'll still get the same answer, which is Li1F1, or just LIF. Okay, so this is what I expect you to do now. Okay, but yeah, I won't ask you to do each and every of these questions. So let's do the odd number ones now. Can you move on to part 3? I mean, like the example number 3, question number 3 now. NA and O. So let's do this together. Okay, so I will give you the atomic number. Okay, or you should always have the periodic table on the textbook open all the time. So this has the atomic number 11. O has the atomic number 8. I wanted to do question number 3 and question number 5 right now.
Yes, sir.
Yes.
If we need 2 and then do we write NA2 and then draw the circle or
Oh.
draw 2?
Good question. Okay, if you need to write 2 of the same thing, I won't punish you by writing it twice or drawing it. Just write 2 times. Yeah, just write 2 times. If you need 2 of something, let's say if you need 2 of Li plus, you just write 2 times on the left. Or if you need 2 of F minus, just put 2 on the left. Okay? Yeah. You don't have to draw it twice. Okay, it's just too much to draw. So you have 2 minutes to work on 2 questions. Yeah, Na and O and Al and O. Yeah, I will give you the atomic number so you don't have to look or find yourself. So this is 13. O is 8. And because they both have O, yeah, it should be relatively quick, this question. Okay, so they both have O. Right. Do the same step. First, find the electron arrangement of each. Think about what 11 can be broken down to. Which 3 numbers can it be broken down to? Like 3 can be broken down to 2 and 1. 9 can be broken down to 2 and 7. So you need to do the same for each of these atoms. From there, you figure out the group number. Once you figure out the group number, you can then work out the charge using that table from before. Yeah, I want to use this exercise to help you remember what the charges are. You can't always refer to the notes. Okay, in the end you can. Yeah, and it is in the last step that you have some flexibility. If you are a very artsy person, you like drawing these puzzle-like diagrams, you can do this. Or if you just want to get the answer straight away, you don't want to draw those puzzles, use crisscross rule. Yeah, you have an option there instead of it. We'll check the answer soon. Okay? Make sure you try. And this type of question will definitely be in the next test. Okay, so if you think, oh, I can do better in the next test, well then this is the part you should work on. Okay. Be careful with these 2 questions because the ratio I can tell you are not 1-to-1. The ratio cannot be 1-to-1 for these 2, and you will see why. Okay?
It's always going to be 2, so it's always going to be 2, 8, 1.
answer to these two questions first. So you should work out the electron arrangement for Na and O. For Na, it should be 2, 8, 1. And for O, it should be 2, 6. Which means the group number is
1, 6.
1 and 6. Yes, 1 and 6. Now, use that like a periodic table I drew you earlier. If something is from group 1 and from group 6, okay, respectively, what are their charges?
Positive 1 and 2, negative 2.
Positive 1 and 2 negative. So you should write Na plus and O2 minus first. Okay? Yeah, so yeah, pay attention first. Okay, what is on this paper. And then what? So, and then just now one student asked me, if Na loses 1 and O gains 2, doesn't that mean the numbers won't match? Yeah, that's exactly what the question is asking you. You will need to have twice as many Na plus. Yeah, compared to just one O2 minus. Okay, so can you draw O? And then what is the new electron arrangement of O2 minus and Na plus after losing and gaining electron? So when Na loses one electron to become Na plus, how many electrons? It will be 2 and 8, right? After losing one electron, its electron arrangement will become 2, 8. What about O? The 2 minus charge suggests that it has gained 2 electrons. So what is the new electron arrangement of O2 minus? 2, 8. Yeah, it will also be 2, 8. It's just that for O, the last 2 electrons you must draw it in a different shape. Okay, you have to draw it maybe in dots or maybe in cross. Okay, in here. So you have 2, 8. Yeah. And Na will have lost 1 electron. So it will be 2, 8. So you have 2, 8. So this is why you have 2 electrons coming from Na in here. And to supply these 2 electrons, you need twice as many Na plus. Okay, a visual way to understand this will be, let's draw this thing on the right. How many sites of depression should Na have? If Na is 1 plus charge, so what should the puzzle piece for Na plus look like? Should they have 1 depression or 2 depressions? Na plus. The plus charge means it's electron short. Na plus means it has 1 depression. Like that, right? This is Na plus. What about O2 minus? O2 minus means it has gained 2 extra electrons, right? So it will be a puzzle piece with 2 protrusions. Yeah. So would 1 Na plus be enough to finish this puzzle piece? No. How many do we need? We need 2. Yeah. So this is why I said for the visual method, you can see that one single Na plus piece is not enough. It doesn't complete the puzzle. You need 2 Na plus pieces. This is why the ratio is 2 to 1. But if you really don't like this method because it's just adding to the complexity, use the crisscross rule. We swap the numbers around. Can you do that now? When you have 1 and 2, when you swap these numbers around, what is the ratio? It will still be 2 to 1, right? Yeah, write down the answer. Na2O. So Na2O is the formula. So this is the answer. This is the answer. Okay, now with the third one, maybe you get a better sense of what is happening now. So, right, let's check the answer because you should also have completed that already. Al, the electron arrangement is 2, 8, 3. O, the electron arrangement is 2, 6. Which means they are from which 2 groups, respectively?
3, 6.
Group 3 and group 6. And according to that periodic table earlier, what is the charge of an ion formed by a group 6 atom?
Negative.
It's not negative. It's 3 plus.
Oh, no.
3 plus. What about group 6?
Negative.
Negative 2. Yes, negative 2. O2 negative. That means in the process, how many electrons did Al lose? And how many electrons did O gain? Al lost 3 and O gained 2. Yes. Now, what's the final electron arrangement of Al3 plus and O2 minus after they gain and lose that respective number of electrons?
2 8.
2 8 for both of them, right? Yes. Okay. Now, the tricky thing is the drawing of the diagram, because you need to figure out where those electrons come from, and therefore use different symbols. For Al, do you draw all the electrons in one symbol or draw them in 2 different symbols for Al3 plus? When you just lose electron, do all the electrons belong to you or do some come from somewhere else? Nothing is coming from somewhere else. So therefore, you use the same symbol. You will just do Al showing 2 and 8 electrons, and don't forget the charge is 3 plus. 3 plus meaning it has lost 3 electrons. What about O? O is tricky. O is tricky. How many electrons should be drawn in a different symbol? How many O? You see, when you say you gain 2 electrons, when you gain $2, those $2 doesn't belong to you originally. It came from somebody else, right? So these electrons have to be drawn in a different symbol. Yes. Is that correct? No. So yeah. So when you gain 1, this is why you have to draw one symbol in a different way. Okay. Yeah. So and when you gain 2 electrons, 2 symbols have to be drawn in different way. And same here. When you gain 2 electrons, 2 of those 8 electrons in the outermost shell have to be drawn in a different symbol. So you have O, and you have 1, 2, 3, 4, 5, 6, 7, 8. 2 minus. Okay, let's figure out what ratio should they be in. Okay, using the Puzzle method. How many depressions should Al3 plus have? A single Al3 plus ion should have. This is what I mean by depression. How many, groups? 3. Yeah, so draw a puzzle piece with 1, 2, 3 depressions. What about O? How many protrusions? 2. Yeah, O should have 2. Now, just like in kindergarten, when you ask, oh, is this a complete puzzle? No. How many of each puzzle piece do you need to complete this puzzle?
2 Al3
You will need how many Al3 plus? 2 Al3 plus. And you will need how many O2 minus? You will need 3. Let me show you one. You put 2 of these, and you will need 3 of these. And you see, it fits. It fits. So the ratio is, you see 2 Al3 plus for every 3 oxygen. So this is why it's Al2O3. So Al2O3. But I know this is complicated, right? Which is why the alternative method is to use crisscross rule. When you put Al3 plus and O2 minus next to one another and you swap the numbers, you get the same answer, Al2O3. Yeah, I encourage students to use a variety of methods because one method that works for you may not work for other students. Okay, so just pick the one you like most. I kind of like this method. It just explains things so much better. Okay, it's perfect. Yeah, completing the puzzle means having a neutral overall charge. Okay, we need to do this because the entire ionic compound must be neutral. I know this is positive charge. I know this is negative charge. But the total number of positive and negative charge should be equal in an ionic compound. This is the basis of this puzzle filling method. Okay? So can everyone follow? Right. Now, the other questions, it doesn't mean you don't have to finish this. You still have to finish the other question. That will be homework. Write down your name on the top right hand corner before you forget. Okay? And we will turn over to the next page and let's finish one question. Covalent compound. Covalent compound, they are a different type of compound. Okay, so put this in here on the new page of your notebook. So covalent compounds, they are formed when non-metal atoms share electrons.
What's your
So they are formed when non-metal atoms
So Na2.
share electrons between them. So share electrons between them. But let's take the first example here, HF. Okay, and I'll show you what that means. Look at H and F. H is a non-metal, so is F. They have atomic number 1 and 9 respectively. That means what's the electron arrangement of H and F? For H, it's just 1. What about for F? 2, 7. Yeah, but we don't do the same approach we did earlier. This time we are asking ourselves, so how many electrons are there in outermost shell? We have 1 electron in the outermost shell. So we have 1 electron in the outermost shell. And we have 7 electrons in the outermost shell. They draw them with different symbols again. Yeah, so this has 1 outermost shell electron. And this has 7 outermost shell electrons. Is this stable? No, they are unstable. So draw this very, very sad face here. However, they can do something to help each other become stable. What is that? It's by sharing electrons. You all know what Olympic rings look like, right? Now we are drawing something very similar to Olympic rings. So let's do this. We will put an H here, and we'll put an F on the side. We draw overlapping circles. When you see the 2 atoms overlapping, it means they are forming a covalent bond. They're sharing electrons between them. Okay, this is the overlapping region. And how do they make each other stable? Hydrogen will put one of its electrons here. Actually, put all of its electrons here because that is the only electron it's got. Chlorine will put one of its 7 electrons in here, and the other 6 will not share. Okay, so can you put this really, really important thing down? What is the difference between the electrons that we put in the overlapping regions and outside the overlapping region? So electrons in the overlapping region means they are shared. Okay, so shared. Electrons outside the overlapping regions are not shared. Okay, these belong to fluorine. Okay, so you can put down these electrons outside the overlapping region are unshared. Okay, outside the overlapping region are unshared or not shared. And this is what forms the covalent bonds. So the shared electron is what forms the covalent bond. The unshared electrons are not responsible. When you're not sharing something, that means that thing is not contributing to the relationship between you and your friend. Let's say you're sharing a book with your friend. Well, the book is a connection between you two. But let's say you have another pencil bag that you're not sharing with your friend. Well, then that pencil bag is not responsible for the connection between you. Okay? So this is what forms the covalent bond. Okay? And now, maybe you don't know why they have to share 2 electrons. But the answer is very simple. Pay attention to what is on the screen first. Can you help me count how many electrons are in this circle right now? 2. 2. In this circle, we need to count also the electron share. So this circle has now 2 electrons, 1 dot and 1 cross, right? What about this circle? 8. By sharing electrons, those electrons belong to both of them at the same time. So therefore, do you see that they are both stable now after forming the bond? Okay, so write down stable. So this is stable. This is why atoms, they like to stick together. Because by sticking together, they help each other become stable. When they were individually not. Individually, they are unstable. Yes? Yeah? Oh, okay. You can come to me after class. Okay, let me because I want to discuss with you one more example first. Which is Cl2. Okay, or maybe O2. Look at O. This is not on your worksheet, but you may write this on your notebook. So O has atomic number 8. What is the electron arrangement?
2, 6.
2, 6. be 6 electrons in the outermost shell. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, quick question. Are they stable?
No.
No, why not? Not a full outermost shell. So let's just write this down. They are both unstable. This is why I draw in red. In red, I try to keep the color consistent. Whenever I use red, it kind of means unstable. Green means stable. Okay? So how can they help each other become stable? Let's explore the different options here. So I have 2 O's. So 2 O's. I can, because a lot of students will ask, so how many electrons do I put in the shared region, right? Okay, how do I decide? Well, let's try. If they put 2 electrons, okay, in this space only, compared to when they put 4, compared to when they put 6, can you tell me how many electrons will be unshared on this O when it donates only just one of the cross electrons? It had 6 electrons. It is now putting just one of the 6 electrons in the overlapping space. So 5 left. 5 left. So can you draw 5 on this circle now? Yeah, these are unshared. Same for the other oxygen. There should be 5 here. Now back to my question. Is it stable?
No.
No. Let's count. You have to be very good at counting. How many electrons do you see in this circle?
7.
7. That means it is still unhappy with what it has right now, so it will try again. So this is wrong. Because oxygen cannot become stable this way. So it is not sharing just one pair of electrons. What about 2? Let's try to share 2 pairs of electrons. How many unpaired electrons will be left
4.
on the left O? Yes, 4. Do we all agree that there are 4 O's? 4 electrons on this one now. Because you had 6, you share 2. That means you have 4 left. You have 6 electrons, you share 2 in here. Yeah, 6 minus 2 is 4. Yeah, so you have 4. So you have 4 also on here. So can you tell me, is it stable now?
Yes.
Yes, because if we count the total number of electrons in this circle, there's 2, 4, 6, 8. So this is how oxygen will form bond. But then, let's also look at the other possibility. What about forming a triple bond? Is it possible that 2 O form a triple bond between them? No. No. Let's see why. When each O contributes to 3 electrons into the overlapping space, so that there's a total of 6 electrons in this overlapping region. How many cross electrons are left on the left O? 3. Yes, because 6 minus 3 is 3. And on the right O also 3, right? Now can you count again? How many electrons?
9.
9. Let's count it together. 2, 4, 6, 8, 9. Is 9 stable? Does having 9 electrons stable? No. Having more than 9 is also not stable. Having more than 8 is unstable. Having less than 8 is also unstable. It's only when you get 8, the perfect number, that's when you are stable. So this is why oxygen, okay, so this is how the 2 oxygen atoms will bond.
So
Do you now, yes,
for drawing covalent bond, you can just skip to the outermost shell, right?
you can just show the outermost shell, correct? Yes, so a very, very good spot, okay. Can you all look at these 2 pages, like right now? What do you notice? When we show ionic bonds, do we just show the outermost shell or do we show all shells?
All shell.
All shells. But when we show covalent bonds or covalent compounds, which shell do we show only? Outermost shell. Can you put this on? You can put it on your notes if you like. For ionic compounds, when you draw them, shows all shells. Yeah, you see 1 shell, 2 shells. I don't care how many shells you have. Show them all. Shows all shells in your drawing. But then, when you ask to draw covalent compound, you show only the outermost shell. Okay? So only the outermost shell. And we can try, I think the bell is about to ring, but we can try the second example very quickly now. H2O. When you look at H has atomic number 1, O has atomic number 6. Okay? H2O means there are 2 H's for every 1 O. Okay? So we will work out the electron arrangement. 1, 2, 4. Sorry, this is 2, 8. It should be 2, 6 because the number is 8. Okay? I wrote the wrong number here. The atomic number is 8. So, and hydrogen has again atomic number 1, which means there's 1 electron. So now we have H, O, and H. Okay? So 1, 2, 3, 4, 5, 6. How many electrons do they each need to share for them to become stable? 1 with each. So we'll draw something that looks like a Mickey Mouse now. H, O, and H. Yeah. Let me just put down the answer, okay? Because I'll pick up from here next time. When the O used 2 of its 6 electrons to share with hydrogen, how many circle electrons are left? 4. We draw them outside the circle. But you see, by so doing, everybody will be satisfied. Why? Can you tell me how many electrons are in this circle? 2. That's enough for hydrogen. Hydrogen is special. It only needs 2. It doesn't need 8. It's full already. This hydrogen is also full. What about this oxygen? 8. Everybody is happy, right? Everybody is satisfied. So this is why we now know it is H2O, but not any other number. So everybody is stable. Okay? Yeah, so you can challenge yourself and finish the other examples here. 3, 4, and 5. And we'll check the answer. It's quite fun, right? And make sure you also finish the ionic compound. Okay, I'll upload the notes. And yeah, we'll continue.
I understand that question. You need to pay attention. Not work on your other subject homework.